All right, so good morning, everyone, and welcome to today's webinar from Research to Award behind the winning papers of the DHC Plus Student Awards. My name is Sara Comparetto. I'm the Engagement Officer for Youth and Cities at Euroheat and Power, and I will be moderating today's session. So thank you for joining this webinar, which is dedicated to showcasing outstanding student research in the district heating and cooling sector. Before we begin, a few practical points. Please note that this webinar is being recorded and the slides will be shared with participants in the coming days. And you're also very welcome to ask questions throughout the presentations by using the chat, and we will address them during the Q&A session. So let me now briefly introduce the purpose of today's webinar. This session is an opportunity to meet the winners of the 13th edition of the International DHC Plus Student Awards. And during the next hour, you will hear directly from them as they present their research, explain their methodologies, and share the key findings and implications of their work. We will also reflect on what participating in the Student Awards means and how this experience can support students and young researchers in the DHC sector. So unfortunately, I should mention that Anna Van Name, the winner of the PhD category, is unable to join us today because she's ill. So we send her our best wishes for a fast recovery. Her work remains part of last year's award-winning research, and we are very grateful for her contribution to the competition. So for those who may be less familiar with this initiative, let me say a few words about the International DHC Plus Student Awards. The Student Awards have been running now for 14 years. They started in 2012, and over the years, they have become a recognized initiative within the DHC community. They celebrate innovative, original, and high-quality student research, covering technological, economic, environmental, and system integration aspects of DHC. And each year, submissions are evaluated by an international jury composed of experts from academia and the industry who assess the papers based on scientific relevance, robustness of methodology, clarity of presentation, creativity, and expected impact. And this slide gives an overview of past editions and winners, and it really shows how far the initiative has come. And we are now launching the 14th edition, which reflects both the continuity of the program and the growing interest from students and young researchers in Europe and beyond. So this brings me to the 14th edition of the International DHC Plus Student Awards, which is currently open. Applications were officially launched on 15 December, and we warmly encourage those who are interested to apply before 15 February. And the competition is open to students enrolled in bachelor's and master's programs, as well as PhD programs at the time of submission. And we are looking for innovative ideas and contributions that can support the transition towards more sustainable district heating and cooling systems. And submissions should address real challenges in the DHC sector. Later today, you will hear directly from last year's winners, which I believe is one of the best ways to understand what makes an application strong and what the jury is looking for. So a key element of the Student Awards is, of course, the jury. And I would like to take this opportunity to welcome our new jury members who are joining the panel this year, and also to sincerely thank those who continue to support the initiative year after year. And we are also very grateful to our sponsor, IADHC, for their continued support of the Student Awards and for helping us empower the next generation of researchers in the DHC sector. At the same time, I would like to mention that we welcome additional sponsors. Supporting the DHC Plus Student Awards means directly investing in young talent and innovative research. So anyone interested in supporting future editions is also welcome to contact me directly for further information. And finally, a few words on what the winners will receive this year. Winning the International DHC Plus Student Awards means more than a financial prize because awardees are also invited to present their research to an international audience. This year, they will attend the Smart Energy Systems Conference in September in Denmark and take part in the official awards ceremony with travel and accommodation fully covered. Plus, their work will also be featured in the International Euroheat Empowered magazine, providing valuable visibility within the sector. So I believe today's webinar is a great opportunity both for those who are interested in learning more about last year's winning research and for those who are considering applying to the current edition of the Student Awards. And now, without further delay, I'm very pleased to give the floor to our first speaker, Sajideh, winner of the Bachelor's and Master's category, will present her paper entitled Data-Driven Approach for Diagnosing Inefficiencies and Optimizing District Heating Networks. So, Sajideh, the floor is yours.
Hello everyone and good morning. Thank you, Sarah, for the introduction, and I would like to also thank the participant and the organizer. I'm Sajida Rustai, and right now I am a PhD student in Politecnico di Milano, and I think I will just straightly go to my presentation. The title of my research is a data-driven approach for diagnosing inefficiencies and optimizing district heating networks. To present the challenge that my research is addressing, I would like to start with this simple diagram that shows how the overall district heating network works. The heat is generated in the plant and then distributed through the supply line to the end users. Each user connected has a substation, and the substation inside the user's building is responsible for transferring the heat from the primary side or the supply side to the secondary or user side. And this heat will provide the need of the user, and the cold water is going to return back to the network. The temperature level on both supply and return line are important, especially the return temperature, which is a key performance indicator of this system because it shows how well the provided heat is extracted in different part of the system. However, many existing networks are struggling with high level of this temperature. And as we can see in this diagram, this temperature is mainly affected by two parts, the substation and the heating devices inside the user's building. Configuration, control strategies, or fault happening at each of these parts is going to affect this temperature. Another equally important issue is related to the variation of the heating demand. Each user connected to the network based on the building characteristic or occupancy schedule or other factors have different heating demand, and this variation makes it difficult for the operators to manage the overall load of the network. This is problematic, especially when we talk about large scale network, when the network is serving like more than 1,000, 2,000 buildings, because each of these individual buildings have their own impact on the temperature and load level and their variation. But the good news is nowadays it is mandatory for the users that are connected to the network to have a digital meter installed in the substation. And these digital meters are constantly recording the operational value related to the users, like the consumption, temperature, and flow rate. If we can use this data and use some machine learning techniques in order to identify the problematic users or the users that are inefficient, and then help the operator to prioritize their intervention, that could be a help for the operator, especially in large scale network. That is what my research is trying to do. We are using here a real operational data of the network, and we developed two different frameworks. The first framework is focused on temperature optimization, and it applies the clustering algorithm on the temperature data of the users. This clustering is necessary because, as you can see in this simple diagram, the type of control strategy that a substation has is going to highly impact the pattern of the temperature. And we need this division because later, based on these results, we are going to assign to each substation a representative temperature metric that can help us to rank the substation based on their impact. And later, having the secondary side data, we are trying to go deeper and see what is the reason behind some inefficiencies in some of these substations. And at the end, we are going to simulate, if we solve this problem, how it is going to impact the overall network. The second framework is focused on the load analysis. Again, we apply the clustering algorithm, but this time on the power data of the users. The primary goal of this framework is first to identify the typical user of the network and the consumption pattern. And the secondary goal is to come up with a methodology to help us to have an estimation of the shape of the profile in the cases when monitoring data is missed or incomplete for some of the users. We applied and tested this framework on a real network located in northern part of Italy. We had the data available for the heating season at a 30-minute interval. On the primary side, we had the data available for around 240 users on return and supply temperature and the power. And for a limited number of users, we had also data for return temperature and supply temperature on the secondary side. So now I would like to start with presenting the result for the temperature optimization framework. First, we applied the clustering algorithm on the primary return temperature, and the algorithm recognized two different clusters inside the data. Around 60 substations belong to cluster 0, that they are showing this fluctuating behavior, and around 92 substations belong to cluster 1, that they were showing this continuous and stable behavior throughout the whole period. Also here, we are just presenting the weekly representative profile for all the users. But as I said, our final goal is to rank the substation based on the impact on the network. So relying on this raw data is not suitable. We need to assign each substation a single value that perfectly reflects their impact on the network. So for all the users that belong to cluster 1 with this stable and continuous heating, a simple average throughout the whole period seemed to be a good representative of them. However, this simple average can't be a good option for cluster 0 because, as you can see, they have these shutdowns that is causing these sharp peaks, and there are some inactive period inside the pattern and inside the behavior. So we came up with different strategies. First, using the signal analysis, we started to identify the peaks that are happening at each profile of the substation, and then we remove them from the data of that substation because they are not the typical behavior of the users, and it's just happening as a result of the shutdown. And then through the percentile averaging, we started to only count the time when the heating device is actually working. And here, we can see an example of a substation that belonged to cluster 0, and the difference between the simple average temperature and the representative temperature that is calculated through this methodology. And as you can see here, this representative temperature is much better reflecting the active period inside the data of the user. Here, we are seeing the ranking of all substations based on this representative temperature metric that was calculated for now on the primary return side, divided by the cluster that they belong to. And as we can see, there are some users that are returning the water with a noticeable high level of temperature, which can be a sign of inefficiency, and it needs to be addressed. So to go deeper and understand what is the reason behind this inefficiency, as I mentioned before, for a subset of these users, around 50 of them, we had also access to the secondary side data. So we started to follow the same procedure of clustering and assigning the representative temperature also for the secondary return and secondary supply temperature. And at the end, for each of these 50 substations, we had these three representative temperature metrics. And from these three metrics, we started to calculate some key differential temperature that could give some hints to the operator about the possible root of these inefficiencies. For example, we started to calculate the difference of temperature on both sides of the heat exchanger, T4 and T3. We usually expect that this difference of temperature should be close, like something around 1 or 2. So we put this threshold of 5 to be on the safe side. And if this differential temperature was higher than this threshold, it is a sign that the problem is in the substation. For example, we can say maybe the heat exchanger is blocked and it is cleaning. In some cases, it might also happen that this differential temperature is lower than 1, which is a sign of misplacement of a sensor because it's physically actually impossible. Another key differential temperature was related to the both side of the heating device inside the user's building. Because we are dealing with a system mostly that are radiator in this case in our network, we consider this threshold as 10, which is a design value for a system like, I mean, higher than 10 actually, which is a value for designing the and sizing the radiators. So if this value was lower than 10, that it was showing the inefficiency is coming from the heating device of the network, of the user, sorry. So at the end, we had this big table in which we had the list of all the users, the calculated temperature metric, and then the identified root of inefficiency based on this criteria. So we go ahead and started to see if we solve this problem and the range of the temperature will go back to the range of the temperature of a normal and a well-performing network, how it is going to impact to the overall network return temperature. So we started to calculate the overall return temperature of the network, which is calculated from the return temperature coming from each building times the flow rate of that building. And we calculated it before and after applying these kind of changes. And as you can see in this graph, if we can address this inefficiency, on average, we are able to decrease the temperature of the network by almost 6 degrees, which is a noticeable value. However, economically, it's not always possible to solve all the inefficiencies inside the network. So we also simulated that if we just address only 10 most inefficient substations, then we are still able to decrease the temperature of the network by 4 degrees, which is still a noticeable value. And now I'm also going to the second framework, which was related to the load analysis, and I'm going to present the data. So here, the clustering algorithm recognized 3 different clusters that here we are seeing, again, the representative weekly profile of the users. And these are the most typical users of the network and their consumption behavior, and some statistical value calculated for the substation belonging to those clusters. This data can help the operators to optimize operation, for example, through managing the peaks, or for it also enables them to have targeted strategies for pricing or for doing some retrofitting. But what we also did was that we assigned a representative profile for each of these clusters that you can see here on the red color, that is showing an average behavior of all substations that they belong to that cluster. If we get a closer look at this representative profile compared to, for example, a real profile of a substation belonging to that cluster, we can see it's like the representative profile is showing the average behavior that is scaled by a factor. It is important because in some cases I mean, in real world, we don't have the access to the monitoring data for the user throughout the whole period. For example, a part of the data is missed. So we started to see if this scaling value can be something that we can find from the real data of the user. For example, if it can be the total consumption of the user or the minimum and maximum value of the consumption of the user. So we started to come up with a scaling methodology to see how much it can give us an estimated shape of the profile of that user. And we calculated an evaluated method by calculating the error that is happening at each timestamp by comparing the estimated shape of the profile with the real shape of the profile. And as you can see here in these graphs, on the individual profile level, the method is not actually performing that much good, and we expect that because we're just dealing with single value. But when we talk about the network, distributing network, what is important for us is the total consumption of the users, not just at the individual level. And the sum scaling method, meaning that only we have the total value of the consumption of the user, is performing very well with the 0% of error. So at the end, I can say that the temperature optimization framework is trying to address the inefficient user, identify the inefficient user, rank them, and then also simulate and see if solving this problem is going to impact the overall network. However, there were some limitations. For example, we didn't model the hydraulic impact of changing of this temperature, and the secondary site data might be limited in some networks. The load analysis framework can help the operators to identify the typical users of their network, and also it can be a tool for them to have an estimation of the shape of profile when they don't have access to the monitoring data of the user. However, there were also some limitation, like the accuracy in the network level needs further validation, and sometimes we don't have access to any real data. It's just the installed power of the user that we have access to. And together, I can say that we're trying to find a scalable and data-driven approach that was reflecting a real industry problem. I was trying to give a tool to the operator to have a practical and cost-effective solution for having more efficient and sustainable networks. Thank you.
Thank you, Sajida, for sharing insights into optimizing district heating networks. I just want to remind you all that you can type questions for Sajida in the chat and we will address them later. So we now move to our next speaker, Gianni, who is the winner of the Best Group Research Project. And he will present his work on performance of a prototype substation for fifth generation district heating and cooling networks. So Gianni, please.
Thank you. Good morning to everyone, and thank you for the presentation and the invitation to the meeting of today. I'm going to my presentation. So today I'm going to present to you the main activities carried out during my PhD course regarding the performance of a prototype substation for fifth generation district heating and cooling networks. First of all, I will present an introduction on the fifth generation district heating and cooling networks, which are many different compared to conventional district heating networks. And then we will move to the objective of these presentations, so to analyze the prototype that you can see on the right of this slide, in the picture on the right of this slide. Then I will explain you the setups, so the aims and of the project and the methods used for the study, the location where the prototype was installed, and also the test performed on the prototype to have as a result the energy consumption of the substation, and evaluate also the performance of the prototype, not only in its operating design, but also of design conditions. Finally, we will see the conclusions. This project was developed in collaboration between the company A2A Calore Servizi, who manage different district heating networks in the north of Italy, and the University of Brescia. So we can start with the fifth-generation district heating networks that compared to a conventional district heating network where the heat is generated into a centralized thermal power plant and the connection between the networks and the houses is direct and realized through a heat exchanger. In a fifth-generation district heating network, heat is shared at room temperature, typically between 10 and 30 degrees. In this way, it is possible to use low-temperature heat sources, both natural or derived from waste heat. However, it is required to install in the substation of the network decentralized heat pumps at building level. In this way, it is possible to cover both the heating and cooling demand of the buildings, and create a district heating and cooling network with just one infrastructure, and increasing the integration of electricity into the heating and cooling sector, and also renewable energies. However, the degree of complexity of this kind of substation increases compared to a conventional one, and the customers of the network are not just users, but they became thermal prosumers because they are able to absorb heat from the network, but also to rely heat to the network. So the main aim of this project was to study the performance of a prototype of a substation for fifth-generation district heating and cooling networks through the realization of a prototype. The prototype serves a real building that has a heating and cooling demand and is equipped with measurement system to enable the acquisition of data on which the performance analysis was based. So we can see the timeline of the project. At the beginning of the project, we performed the literature review and the design phase in order to design the prototype to be easily replicable on a large scale, and then we realized the substation and the prototype, and put it into operation and started the acquired data on which the performance analysis was based in order to derive as results the energy consumption in the on-design conditions, but also to verify the performance of the prototype over a wider operating range compared to the one of the specific case of study selected. The location selected for the installation of the prototype was the power plant in the city of Brescia. Brescia has district heating and networks, and one of the plants used to serve the district heating network of the city was used as the location to install the prototype due to the reason that was available a low temperature heat and a building that has a heating and cooling demand. So the idea was to use the prototype substation to cover the heating and cooling demand of the building using the low temperature heat available on the plant from the evaporative towers. So the idea was to realize a fifth-generation pilot network to connect the evaporative tower circuit to the prototype substation and use it to cover the heating and cooling demand of the network. The substation is consisting of a bidirectional pumping system, a reversible heat pump, and an inertial thermal energy storage. Moreover, was added also a heat exchanger to be able to test the heat pump over a wider temperature range compared to the temperature available from the evaporative towers. We can see some picture of the installation of the network on the left and of the substation on the right. The network was realized with uninsulated pipes. And you can see the main component that I have introduced before in the picture on the right that shows the substation. Then was also performed the data acquisition system that allowed to acquire the data of the prototype and also historicize it in order to be able to perform the analysis. And then through this system, it was also possible to write the new set point and parameter in the main of the different components in order to test the performance of the prototype under different operating conditions. Having realized the prototype, we began the test, and here we can see the result of the test performed on the on design conditions. So with the same temperature available at the evaporator available from the low temperature waste heat in the power plant, and with different temperature at the condenser of the heat pump that you can see in the four charts. Each chart represents the daily electricity absorbed by the substation, and each bar represents 1 day of performance split into the electricity consumption for the main components of the substation. So the heat pump in blue, the pumping system in orange, and auxiliaries in yellow. You can see also the percentage of electricity consumption for each component, and you can see how the pumping system, the consumption of the pumping system is not negligible. This is one of the main features of this kind of network, where the temperature difference between the supply and return line is reduced, and so the flow rate of the network increases a lot compared to a conventional networks. We analyzed also the key performance index, in particular the COP of the heat pump and the global COP, calculated as the ratio between the heat provided to the building and the total amount of electricity consumption from the prototype. And you can see the results in terms of COP that goes from 3.3 and 4.2, and the global COP that decreased to 2.6 and 3.1. We perform also tests under off-design conditions, where we change the temperature of the evaporator to simulate different kind of low temperature heat with temperatures between 10 and 30 degrees, and with different temperature at the condenser to simulate the different kind of heating system, from radiant panels to fan coils and radiators. So temperatures at the condenser was into the range between 40 and 65 degrees. So you can see the the purpose was to obtain one function as the one that you can see in this slide, where the COP is represented as a function of the temperature at the condenser and the temperature difference between the condenser and the evaporator. And you can see the COP values that are in the range between 2.8 and 6.1. Obviously, reducing the temperature at the condenser and decreasing the temperature difference between the condenser and the evaporator, the COP values increases, and so the performance of the prototype are the best. The same things we perform also in the cooling configuration, so using the heat pump as a chiller and providing the cover the cooling demand of the building. So here you can see the consumption, the electricity consumption of the main components of the substation, and we perform also of design test to evaluate the performance of the chiller in different operating conditions in terms of temperature, both at the evaporator and at the condenser of the chiller. So we can finally we perform a comparison between a conventional substation connected to the district heating system operation and the fifth generation prototype, substation prototype. You can see on the left the data, the input data for this analysis, and on the right the results for this analysis in terms of primary energy. We can see how the conventional district heating networks have seems to be the best solutions because it requires a lower value of primary energy in terms of megawatts hours required to satisfy the heating demand of the building. However, in considering the CO2 emission, we can see how the fifth generation district heating cooling networks appears as the best solution. We was also interesting to evaluate the flow rate required by the fifth generation district heating network, that is one order of magnitude higher compared to the conventional district heating networks, that is connected to the main feature of this kind of network that I explained you before. So we can go to the conclusion of this study. Here, there are some evaluation considering the fact that the main components, so the heat pumps and the pumps, was not equipped with inverters. So it is possible to increase the performance of this kind of networks using inverters of component as the compressors of the heat pump, reducing the number of run on and off of the heat pump and increasing its operation. Then the prototype was designed in order to be easily replicable on a large scale and to be controlled remotely, changing the configuration between the heating and cooling configuration remotely. Then we realized the grid through the uninsulated pipes, but it is possible also to realize this kind of grid through the polymers pipes in order to reduce cost. Then we evaluate also the pumping consumptions that is not negligible for this kind of application. And we use a heat pump that has as a refrigerant R134A. This refrigerant allows to reach good performance, but has a high value of global warming potential. So we also moved to selected other refrigerant in order to have a low value of global warming performance, but the same performance. And finally, all the data derived from this project can be used as input data for techno-economic assessment for future installation of fifth generation district heating and cooling networks. This is all. Thank you for your attention, and I'm here for any questions.
Thank you so much, Gianni, for your presentation and also for sharing the innovative solutions that your team has developed for fifth generation DHC networks. And I would also like to highlight 8-way inspiring commitment in supporting young generations and their involvement in education and training activities, as they will also host the next edition of our International DHC Plus Summer School in Brescia. So with that, we have now reached our Q&A session, and I still encourage our audience to type your questions in the chat, and we will address them together with Sajide and Gianni. And in the meantime, I have a couple of questions for you that might be interesting for our participants as well. So maybe we can start with Sajide. I have a question about return temperature, and why did you choose it as the key performance indicator in your research?
Because when we talk about the return temperature and reducing it, it will have effect on the overall network in different ways. For example, having the lower return temperature means that lower operational cost, because we are going to have less emission losses inside the network. Also, it will also decrease the pumping cost because we have more differential temperature and then lower flow rate required to meet the same amount of the heat. And also, I mean, we all are talking about district heating as a way to decarbonize the cooling and heating sector. So in order to integrate the renewable sources of energy in the production side, we need lower level of temperature because usually these sources are able to produce the heat at lower temperature. And also, what I can say is that it's also I mean, indicator that is mainly affected by the performance of the users and also the substation performance, which is like a practical indicator for operators to identify inefficiency, and this is something that they can actually address.
All right. Thank you. So we have a first question. They congratulate on both of you, and so what drew you to district heating and cooling, and how do you see your future career in this field?
Mhm. Actually, it was, I mean, my major is building engineering, and for my thesis, actually, I worked on this topic. It was like the first research that I did in this whole area. But it was really interesting for me because, I mean, before I wasn't really familiar with the potential that the district heating and cooling has. And then I started to work on this topic, and also especially the topic that I mean, I was developing in terms of the data analysis. I saw a lot of potential in the area. And also, I mean, the whole award and everything that gave me the opportunity to go to the meeting and present my research gave me this maybe I can say this kind of encouragement to follow my research in this area and try to address the problem that are something that the real networks are dealing with.
Thank you, Sajida, for sharing your experience. And what about you, John?
Okay, I think that the main reason why I began to study and make research in this sector was due to the theme of energy in general, and in particular the energy required to heating and cooling the houses, and that is one of the main energy demand in Europe, and so it is crucial to know and also try to increase the renewable energy uses, in particular in this kind of sector. So I was attracted to this challenge, and I was really interested to discover this word, and in particular also the operating some operating features for district heating and cooling networks. So I started for this reason to study and make research in district heating and cooling sector. Then I moved to the company HOA Calore Servizi, where I work currently, in particular in the R&D department, where we are perform some project in order to increase the decarbonization of our district heating and cooling networks through the realization of thermal power plant that increase the use of waste heat or the renewable energy, such as geothermal energy or waste heat that comes from industry or data centers or other kind of waste heat. So this is currently my work. My job.
Thank you, Gianni. And maybe since both of you come from Italy, it would be interesting to maybe share how how the sector is, how's the development of the DHC sector in Italy, how hard it is to further develop the transition to a sustainable district heating and cooling system.
Okay, I can start.
Yes, John.
Okay. I think that in Italy, district heating is mainly developed in the north side of the country because is for the weather of Italy, where in the north of the country the winter is the temperature during the winter are the lower compared to the other part of Italy, and are mainly based on all those networks are mainly based on the fossil fuels plants. So we as A2A, but probably also the other companies are trying to move from this kind of heat sources to other sources more sustainable. In particular, one of the main feature of district heating is the possibility to switch from fossil fuels to other fuels or renewable energy or waste heat recovery, and this is one opportunity compared to other solutions, as boilers installed in each building where are more difficult to change, and so I think that district heating can be seen as a solution to the decarbonization of the energy sector, especially on the heating and cooling demand, to cover the heating and cooling demand of the building.
Thank you, Gianni. Sajida, do you have any comments on that? Maybe also from the university perspective?
Yes, actually, as we all know, the district heating and cooling is seen as a main solution for decarbonizing the sector. So also in the university, I see that there are different groups working on the topic, trying to address the issues that already exist inside the network, working on the real example inside the Italy. So I think alongside other countries inside the Europe that are trying to progress in this field, also Italy in the both research and industry sector is trying to go ahead and move with the other countries and try to develop innovative solution, especially for moving toward the low temperature district heating, which is seen as the next generation of this system.
Thank you, Sajida, for sharing also your point of view. And maybe it could be interesting for also those who might be interested in applying to the next edition of the Student Awards, to share both of you how participating in the competition actually influenced your research direction and motivation. Sajida, if you want to start.
Okay. Yes, actually, it was a really good encouragement for me at the start of my journey in the field, because first it gave me the opportunity to present my research, and I could get some feedbacks from people in industry and from other people that are working like as researchers like me, and also the fact that I could also participate in the symposium and see other research that is already done in the area. It gave me kind of a line to follow and try to see what are the real challenge and what are the points that need to be addressed inside the industry. And I think it also helped me to shape a kind of clear path for my research in the future.
Thank you, Sajida. It's great to see how also participating in this kind of activities can boost your research and motivation. And what about you, Gianni, since you're also already involved in the industry side?
For sure, it was a great pleasure to present my work to the main district heating including community of Europe, and have the possibility to share the results that I achieved with them in order to have some feedback from all the people who worked for many years in this field, and to increase also the network of the network of people who work on district heating and cooling sector. So it is helpful because they can suggest to you some new topic in the field, or suggest you some other test to perform on your prototype, or other topic that you can go inside to increase your knowledge in the district heating and cooling sector in general.
Thank you, Gianni. Yes, I believe it's nice to see that you also managed to mobilize, let's say, part of the industry to get more involved. Maybe another questions for you both about your experience with this initiative. Why do you think the project that you both presented achieved this positive result and managed to win the award? Maybe Gianni, if you want, you can start.
Okay, I think that the main feature of my project is the team that allowed to realize all the project from the design phase to the realization of the prototype, and then also all the test phase to analyze the performance of the test. It was a great opportunity for me because I was just it was my first real job out from the university, and no, I learn a lot from all my colleagues that help not only me but all the project to be realized, and I really learn a lot on the field for the project, for all the components, the operation of all the components, and I try to describe all this in my PhD thesis, and also in the presentation and in the paper that I presented in the District Heating and Cooling Awards. So I hope to have reached this goal.
For sure. Thank you, Gianni. And what about you, Sajide?
Okay, first, I'm sure that the other researchers have been also valuable. I mean, they offered valuable results, but I think what is the reason that my research was awarded is that I try to address a topic that is that the challenge that exists right now for the transition of this system to a more sustainable system. And also the fact that I try to use the data, because I mean, nowadays, thanks to these meters, we have high availability of data, and also we have some machine learning techniques that we can use them to analyze this data, and somehow having all these together in order to address this challenge inside this industry, and offering a practical maybe network that can be used for the operators was the reason that the paper was interesting for maybe the jury. because it was trying to address a kind of real issue with a practical solution. I hope, actually, at least I hope it does.
Of course, I'm sure the fact that it addressed real challenges was something that jury appreciated. And then maybe you have one final recommendation for those students who are considering applying to this edition.
I think for me, I don't know, maybe there are other, I think it's maybe a common issue between all the researchers being like a bit perfectionist, but I think the most important thing is that you go on what you do and just try to present whatever you have, because at the beginning I wasn't thinking that it's something that is going to win. I just wanted to give it a shot. So I think that's it. Even if now you think that it's not something that is, I don't know, that much considerable, but just go on and do that and try it, and I'm sure you're going to get a good feedbacks.
Thank you, Sajida, for your advice. And what about you, Gianni?
I'm agree with GDZ. I really invite all the people to try to write the paper to be able to present at the District Heating and Cooling Awards, because it's a really fantastic experience, but help also you to be able to perform better in your research, because it is a way to see and analyze all the job that you have done on the project, and so it is helpful also for you, and not only for the community of District and Cooling Network.
Thank you, Gianni. I totally support both of your recommendations, and I think we've reached the end of this webinar. So thank you both for sharing your research and insights, and also thank you to all of our participants for your attention and being with us today. So I just wanted to give a quick reminder about the 14th edition of the DHC Plus Student Awards, as there is only 1 month left to apply. So all information about application guidelines and questions are available on the EuroHeat Empower website. So just don't miss this opportunity to showcase your research and make an impact in the DHC sector. And also, before we close, I'd like to invite you to the EHP Congress 2026, which will take place from 9 to 11 June in Krakow, Poland. So the Congress is our flagship business event and the largest gathering dedicated to district heating and cooling in Europe. So registrations are now open, and it's a great opportunity to connect with the industry leaders, learn about the latest developments in the sector, and shape the future of sustainable heating and cooling. So thank you all once again for participating. Have a great day, and goodbye.
Thank you, everyone.
Thank
Bye.
you. Bye bye.
Bye.